Good evening. My name is Rob Leyden. I'm a director emeritus here at this center, and I'm pleased to welcome you to the 12th Chatham Marconi Speaker Series presentation of 2025. We're fortunate to have Tom England with us tonight. His presentation is entitled Reginald Fessenden, Brilliant Inventor, Unsuccessful Radio Entrepreneur. Reginald Aubrey Fessenden, Marconi contemporary, made significant advances in radio technology from 1900 to 1911. His work was focused on continuous wave transmissions with the goal of transmitting sound over radio waves. He was the first to demonstrate practical radio telephony, and several of his other innovations made their way into the Chatham RCA station. However, his track record commercializing inventions was less impressive. Some of his inventions were ahead of their time, but he was also unable to manage ownership issues with financial partners. Tom will look at his life, selected radio inventions, business activity, and contrast his contributions to that of Guglielmo Marconi. Tom earned a PhD in organic chemistry and spent 35 years in consumer and healthcare product development. He holds 12 patents as a registered patent agent and adjunct professor at the University of Cincinnati School of Pharmacy. His lifelong interest in radio began at a young age, when he imagined radio waves traveling across the Atlantic Ocean to France while visiting his grandparents at the Jersey Shore. It wasn't until later he realized he sometimes was looking west across Delaware Bay. An amateur radio operator since high school, his retirement volunteer gig at the Marconi RCA Wireless Museum is a dream come true. He is currently a museum docent and secretary of Chatham Marconi's board of directors. Following this presentation, Tom will answer your questions, and it's now my pleasure to introduce Tom England.
Thank you, Rob. Thank you. As a museum volunteer, I've learned quite a bit about Marconi, his life, his achievements, and his commercialization successes. And that made me curious about a number of the other early pioneers in radio. So this evening, I'd like to share with you the story of Reginald Fessenden. In summary, it is the story of a brilliant inventor and prolific inventor, but unfortunately, he was not very successful in commercializing his inventions. So I think he's an interesting contrast to Marconi, who was not as prolific an inventor, but was brilliant at commercializing radio. So at the risk of leaving out some very important inventions, I'm going to focus on a few foundational ones in radio. First is Fessenden was probably one of the first to communicate voice over radio in 1900. And he was really interested in continuous wave transmissions as opposed to spark, which produces damped waves. And because of that, it led to the creation of the radio frequency alternator, which plays a role here when they're installed at Marion, our transmitting site, and used from here. He also developed some more sensitive detectors than were in use at the time. And importantly, they were able to detect or demodulate sound on radio waves. And the last one I'm going to talk about is heterodyne mixing of radio frequencies. And that's been used in high performance radios since the 1910s. Unfortunately, that gets contrasted to his commercialization efforts. For 2 years, he worked with the U.S. Weather Bureau, and he was able to demonstrate that he could transmit weather information from station to station. But because of some patent ownership issues, that effort was abandoned shortly afterwards. And then he was the principal in the National Electric Signaling Company, which demonstrated both transatlantic radio telegraphy, that is Morse code over radio, and short distance radio telephony, voice over radio. But again, that didn't result in a significant business success. After 1911, he turned his focus to underwater sound, sonar. And a lot of his work is important in World War I, but he doesn't come back and do anything with radio. Reginald Fessenden was born in the fall of 1866 in a town called Bolton in what was then known as East Canada. Today we would call it Quebec. He was the oldest of 4 children. His father was a minister in the Church of England in Canada, the Anglican Church. And his mother is actually more well-known, Clementina Trenholm. She was an author and an activist. She campaigned against women getting the right to vote in Canada. And she also was an avowed Anglophile, and she campaigned for Canada to celebrate Empire Day, which was a celebration of the British Empire in Canada. And then the picture of her there, she's dressed in black mourning because, like Queen Victoria, she wore black for several years after the death of her husband. Fessenden's father was posted to a number of different churches across Ontario. And so Fessenden moved to several different schools, but he appeared to be a bright student very early. So at age 14, they send him off to his father's alma mater, Bishop's College School, which was in now the province of Quebec. And while there, they actually have him teach math to other boys, both older and younger than himself. And then they give him a scholarship to the college side of Bishop's College, where he first begins to read technical journals like the Scientific American, Nature, and other engineering journals of the time. He spends 4 years there. He accomplishes all the requirements needed for a degree, but he decides to leave before they confer the degree on him. And this actually becomes a problem later in life. He's turned down for a professorship at McGill University because he doesn't have a formal degree. So he leaves Canada to go to Bermuda. And at age 18, he becomes the headmaster of the Whitney Institute in Flats Village, Bermuda. It sounds a little fancier than it was. He was also the sole teacher of 25 boys. But it wasn't all work and no play for Reginald. During that time, he meets, courts, and gets engaged to Helen May Trott. Helen's family is a long-term resident of Bermuda. In the picture in the lower right, Fessenden is the tall gentleman in the back. He was very tall, broad shoulders, very imposing. And to our right, the woman in white standing next to him is his wife, Helen. But again, his wanderlust kicks in, and after 2 years, he decides to leave, and he goes to New York. I assume from reading journals like Scientific America, he has the desire to work for Thomas Edison. So he works his way all the way to the New Jersey labs of Thomas Edison and manages to get an appointment to meet with the famous inventor. When asked to write down his business with the inventor, though, he makes a fatal mistake. On the card, he writes, "Do not know anything about electricity, but can learn pretty quick." He also probably had a little grammar problem there. Edison writes back, "Have enough men who do not know about electricity," and he doesn't get the interview. So he goes back to New York City where he's living, and he's quite persistent. He notices that the Edison Power Company is laying power cables in the streets of New York City. And he befriends one of the foremen. And being very persistent, he bugs him. He finally gets a job as assistant cable tester as they lay the cables. He must have done very, very well at that job because he works his way from there all the way back to the New Jersey lab. And at one point, he solves a problem with the flammability of the insulation on electrical wiring by adding antimony chloride, which is still used today. And so when the position opens up, Edison gives him the role of head chemist. So here he is in his dream job, and unfortunately it comes to an end. In the summer of 1890, Edison is in Europe, and there's a financial panic on Wall Street. And his financial backers decide that they need to cut the payroll. And they lay off a significant portion of the lab employees, including Fessenden. But here he is, he's lost his dream job, but he's undaunted. He and Helen decide that their engagement has gone on long enough. So she comes to New York City, and in September of 1890, they're married in Manhattan. Helen wrote a biography about her husband, and in it, she mentions that he spent all of his savings on her wedding ring. So for their honeymoon, they go and visit his parents in Canada, because that was all her meager savings could cover. I'm going to jump ahead a little bit. In 1893, they have a son, their only child, Reginald Keneally. And then in this picture on the right-hand side, Reginald is in the back standing, and his wife, Helen, is in the back on the left side. The two people in the front are Reginald's parents. And then washed down in this old photo in white is poor Reginald Keneally, dressed in white at 3 years old. His parents called him Ken. The name Keneally might sound familiar with those of you who are radio buffs. Reginald met Arthur Keneally while he worked at Edison's labs, and they remained friends and scientific collaborators through most of their life. Well, Arthur Keneally, along with Oliver Heaviside, in about 1902, predict the existence of the ionosphere, which is what allows radio waves to bend around the curvature of the Earth, and in fact allowed WCC to work ships as far away as the Indian Ocean. He bounces around through a couple of different short-term engineering jobs and then gets a break. At age 26, he's named to be a professor of electrical engineering at Purdue University. And while there, he helps Westinghouse with an important problem. The Westinghouse Corporation had won the contract to light the 1893 Columbian Exposition that was to be held in Chicago. Of course, they're going to use alternating current since it's Westinghouse. And they had to work around Edison's patents on light bulbs. So they had this resealable light bulb, but they were very short-lived. And so Fessenden helped by coming up with a new way to seal the bulbs by changing the metallurgy of the wires that were used to bring the current into the bulb. This draws the attention of George Westinghouse. And so within a year, George Westinghouse uses his influence to get him a position of the chair of the electrical engineering department of the Western University of Pennsylvania, which we know today as the University of Pittsburgh. And while there, Fessenden experiments with a number of different things, X-rays and other popular physical phenomena of the time. And by the late 1890s, news is reaching America of Marconi's successes with electromagnetic waves. So Fessenden gets interested in radio, and he develops his own receiver, a receiver of his own design, and he manages to communicate using spark telegraphy between Pittsburgh and an outlying city known as Allegheny. And during this time, he gets interested in radio telephony, so sound over radio waves versus radio telegraphy. And he becomes convinced that continuous wave transmissions are superior to spark transmissions. In spark transmissions, the wave dies out and you have to keep repeating the spark to create the wave. Continuous wave transmissions would look like, if you could see it, just a sine wave that's continuous. This was contrary to established radio theory. At the time, it was believed that a spark was required to make radio waves. They called it the whiplash effect. And even as late as 1906, Ambrose Fleming writes a treatise in which he says that continuous waves are not likely to be successful and sparks are required for radio waves. So he gets notice from his work at Pittsburgh, and the Weather Bureau calls upon him and, as they say, makes him an offer that he can't refuse. The Weather Bureau was using landline telegraphy to pass weather information between stations, and that was quite costly at the time. So they thought that they could use radio to do it more cost effectively. So the offer they make him is a stipend of $3,000 a year, which in today's dollars is a little over $100,000. They're going to provide him housing, experimental facilities, and technical assistance. Now, Fessenden's understanding of the agreement is that the Weather Bureau can access his inventions, but he keeps the ownership of the patents. So we'll come back to that in a moment. Well, the housing they offered was actually on Cobb Island in Maryland. It sits in the Potomac River, about 50 miles east of Washington, D.C. And Helen, in her biography, describes it as quite rustic. There were only 2 habitable buildings on the island. There was a single slow trickling stream, which had to provide water for both the human inhabitants and all the livestock. And she talked about the proliferation of ticks and mosquitoes, exactly what you expect on an island in the middle of the Potomac. But this is actually a quite fruitful time invention-wise for Fessenden. They put up 2 towers, 150 foot tall. They're about 100 miles apart. And they also have a station in Arlington, Virginia. So what I'd like to do then is let's look at some of his inventions quickly. Here in December of 1900, while on Cobb's Island, he conducts what might be the very first radio telephone transmission. And just to place this in time, remember it's a year later that Marconi reports hearing the letter S across the Atlantic in Newfoundland in 1901. Now, the problem, I want to describe the problem so you can understand what he's up against. In sparks, if you're using a detector that can detect or demodulate sound, you're going to hear the buzzing of the repetitive spark. So I'm going to play an audio file for you here that shows you what a spark signal would sound like on a receiver capable of listening, of hearing sound. And this was a simulation done by John Belrose back in 1994. So that's that repetitive buzzing. So how are you going to put sound on top of that? Very difficult to hear. From his time with Edison, Fessenden became a rigorous experimenter. And so he starts experimenting with different frequencies of the repetitive spark. And he realizes that he can hear the tone that it makes. If he sparks it, say, 500 times per second, he can hear a tone that sounds like 500 hertz. So he comes to the conclusion if he could just make the spark repetition fast enough to move it out of the audio range, it would just be kind of white noise in the background. So his assistants create a spark interrupter that will work at 10,000 cycles per second. And John Belrose recreates this by making an instrument to do that and listens on a crystal receiver. I'm going to play for you this simulation. What you're going to hear at very low level is the words that I show on the slide there. And this was transmitted on Cobb's Island.
Hello, 1, 2, 3, 4. It's snowing where you are, Mr. Stephen. You better telegraph back and let me know.
Well, Mr. Thiessen's only a mile away, so it was snowing there as well. And he does telegraph back that it's snowing. So while this is a crude beginning, it is actually a beginning for radio telephony. He realizes to be successful in radio telephony, he really needs continuous waves. And in 1901, he files a patent for the radio frequency alternator. He calls it a dynamo. And remember, he came from Edison's power company and Westinghouse doing alternating current to light bulbs. So he's able to bridge power generation to radio wave generation. And in his patent, he talks about a dynamo, an alternator, that operates at a frequency that is the same as the resonant frequency of the antenna system. And he contracts with General Electric at this point to build him a radio frequency alternator. And his specifications are that it can produce about 1,000 watts at a frequency of 100 kilohertz or 100,000 times per second. So we're going to come back in a few slides to the progress that General Electric's able to make there. The other thing he realizes he needs is more sensitive detectors and detectors that can demodulate sound so you can hear the sound. At the time, he was working with a detector called a hot wire detector, and it required a very thin wire. And the way they made that is they took a thicker wire, which was platinum on the inside, coated with silver. And they would put the wire into nitric acid and dissolve away the silver, leaving a very thin platinum wire. Well, one day, maybe through a mistake or whatever, the wire broke. And they end up with a short piece of platinum wire right at the interface with the nitric acid. And Fessenden says, well, let's try that anyway. And it turns out that's a really good detector. Probably there's several theories on how it works, but that junction acts as a semiconductor junction, and it can detect radio waves and conduct the sounds in there. This actually becomes a popular, this becomes a popular detector, and it was used even on shipboard once they come up with a sealed version. Who wants an open cup of nitric acid on a pitching and rolling ship? So he has success at with the Weather Bureau, and so they decide to move to a full-scale demonstration. And they set up 3 stations. The main station's on Roanoke Island in North Carolina, and the other 2 stations are on Hatteras and Cape Henry, Virginia. And in 1902, they set up a public demonstration in which they have the military there, they have other agencies of the US government. And there's an interesting anecdote that happened during here. They had a whole plan of messages that they were going to transfer between Hatteras and Roanoke. But the head of the Weather Bureau, Chief Willis Moore, wanted to reach Fessenden that day, and there wasn't direct telegraph line to Roanoke. So he actually sends the message to Hatteras, and during the demonstration, they pass the message on to Fessenden in Roanoke, and it's a 127-word message. Well, the success of this demonstration makes it to the front page of the New York Times on April 27th, 1902. And what might be hard to read there, the third subheading, experts observe invention of Professor R.A. Fessenden of the Weather Bureau, by which a 127-word message is sent 50 miles. So suddenly everybody knows about his success, and orders begin to come in from government agencies in the US and even from Mexico. With that success, Willis Moore, the chief of the Weather Bureau, decides that the Weather Bureau should share in these successes, and he wants to be named on the patents. So the Weather Bureau would have some ownership of the patents, and he wants to split the income with Fessenden. Fessenden refuses, continuing to believe that the agreement that they had was that the patents would belong to him. So the Weather Bureau cuts off his income and all of his support, and Fessenden resigns. The Bureau tries to continue the effort for a few months and then gives up, and the equipment's auctioned off. So this is our first time that over a disagreement of ownership, we see Fessenden having a significant successes, but not able to convert it to commercial success. So Fessenden now is kind of in a crisis, right? He's been very successful, has some interesting inventions he'd like to pursue, but he has no money, he has no backing. His patent attorney in Pittsburgh, Darwin Walcott, comes to the rescue. And he comes up with the following plan. They're going to create a company called the National Electric Signaling Company, which I'll just refer to as NESCO. And all granted and pending Fessenden patents will be owned by NESCO. And then 2 prominent Pittsburgh businessmen, Hay Walker Jr. and Thomas Given, agree to invest. And the agreement is this. They're going to put up $30,000 so that Fessenden can build some demonstration stations. And if he's successful, they have the option to buy 55% of NESCO in the first 9 months for $300,000. So if you think about it, $300,000 for 55% of Fessenden's patents, make them worth $550,000, which in today's money is about, sorry, I forgot the number, is about $21 million. So there was a significant patent portfolio. Fessenden does build this station successfully. They build one in DC, Washington, DC, and two in New Jersey, one in southern New Jersey near Philadelphia, and one in northern New Jersey near New York City. And the idea is they're going to move traffic messages up and down the East Coast. One of the inventions he comes up with along the way is related to his continuous wave technology. The issue is with a continuous wave transmission and a receiver that will receive sound, you won't hear anything. Remember, in Spark, you hear the repetitive spark buzz, but you actually won't hear a tone. And he comes up with this idea of heterodyne mixing of radio waves. If you mix two frequencies together, you get four frequencies out. You get the original two that you put in, and you get the frequency that is the sum of the two you put in, and you get out the frequency that is the difference between the two frequencies you get in. And you may have actually seen this used in music. In sound, if you want to tune, say, one instrument to another, you both play the same note, and you'll hear in your ear the difference. And if there is much of a difference, you can tune one of the instruments to make that difference note, that beat note, near zero. So in Fessenden's case, his idea is, suppose he's receiving a radio signal at 20,000 hertz, 20 kilohertz. He would mix it in the receiver with a signal of 21 kilohertz. The difference between those two, 1,000 hertz, would come out as a tone that you would hear the dits and das of Morse code. Unfortunately for Fessenden, practically, this invention is ahead of its time. The only way to make a stable, there wasn't a good way to make a stable second frequency. And the only way at the time would be another alternator or what was known as the oscillating arc. Both are large, expensive machines, hard to keep stable. So practically, there was no way to do this in 1905. It turns out in 1912, Major Edwin Armstrong invents the vacuum tube oscillator, which allows a very easy way to make that local second frequency. And then this idea could be used. And we'll come back to that. 1903, we're all familiar with 1903 in Wellfleet, Massachusetts. Marconi demonstrates transatlantic radio telegraphy by sending a message from President Teddy Roosevelt to King Edward VII of England. So NESCO changes its business strategy. They're now going to offer transatlantic telegraphy service. And the two locations they pick is one right up the road here called Brant Rock, Massachusetts. Brant Rock is about 10 miles north of Plymouth. It's a small piece of land that sticks out into the bay. And the other end of the circuit was going to be Machrihanish, Scotland. The path, the direct circle route between those two locations is almost all over saltwater, goes up the Bay of Fundy. So it was good planning. They're going to use a Fessenden-designed rotary spark system, so they're still using spark. And they're using a vertical antenna. The antenna itself is insulated from the ground with a large glass insulator. So the pole and that wire cage at the top are all actually the transmitting part of the antenna. And in January 1906, they are able to successfully transmit two-way messages between Scotland and Brant Rock. And at this point, Fessenden does some nice work with studying propagation as a result of frequency, time of day. But unfortunately, as January becomes spring and spring becomes summer, they're using very low wavelengths which are absorbed during daylight. And there's very high static levels in the summer. So they're not able to sustain the circuit in daylight, and then eventually by summer they can't reach either one. And then unfortunately, in early December of 1906, a gale goes through Scotland and blows down the antenna in Scotland, and it's not put back up. So that is the end of NESCO's transatlantic strategy. So at this point, I'd like to come back to this radio frequency alternator. General Electric had worked on it and produced an early prototype around 1902 or 1903, which didn't work well enough to be a transmitter. So they put a young engineer named Ernst Alexanderson on the project. And in 1906, early 1906, he delivers a radio frequency alternator that's capable of up to 100,000 hertz and about 1 kilowatt of power. So they install it at Plymouth, Massachusetts, and on December 21st, 1906, sets up another public demonstration. They have representatives from the telephone company, Associated Press, General Electric, and so on. And this demonstration gets well documented in the literature. They use an electrolytic barretter detector, the platinum wire dipped into nitric acid. They do speech. They transmit music from Brant Rock to Plymouth, a distance of about 10 miles. And in fact, they actually arrange a telephone line from Plymouth to Brant Rock, and they couple that to the transmitter so that someone can speak at Plymouth and hear their own voice coming back to them by radio from Brant Rock. The other thing that's anecdotally known is that while they were doing a lot of testing leading up to this demonstration, before the tower blew down in Scotland, they heard some of the testing signals in Scotland. And so it may be the first time there was radio telephony across the Atlantic. So at this point, we've kind of reached the pinnacle of Fessenden's radio inventive career. And following the successful demonstration on December 21st, Fessenden reports that he makes a broadcast program on Christmas Eve of 1906. And that it's heard by shore stations and ships along the Atlantic seaboard as far south as the Caribbean. And his program includes a number of offerings, mostly by Fessenden himself. It turns out his assistants and his wife had microphone fright, but it turns out the microphone is in the antenna circuit, and touching it might electrocute you. So it's kind of understandable that they chose not to be on the first broadcast. Now, there's a lot of controversy about this. There are no contemporary reports of this broadcast. So there's nothing in the newspapers. No one's been able to find ship's logs reporting the broadcast. What we know of it was principally from a letter that Fessenden wrote in 1932, many years afterwards, in which he described the program. There is a brief mention in a talk given by one of his associates in 1928, but there's no details given. So again, we reached kind of the pinnacle of his career, and we're not really sure it happened. So let's look briefly at his commercial legacy, and then we'll look at his technical legacy, and then I promise I'll wrap up. So we already talked about the Weather Bureau. He had very successful demonstrations, but the efforts abandoned in early 1903. Now, the National Electric Signaling Company made some progress, but not as much as you would hope. They did fulfill a contract with United Fruit, which was based in Boston, to provide some radio equipment for their ships and their shore stations. They sold the electrolytic barretter, but unfortunately it was widely copied by other companies. So they didn't make a lot of money from that. And then unfortunately, and ironic, they had a Navy contract, but they lost it. And the story goes like this. They won a contract with the Navy to supply transmitters for their Arlington, Virginia station, which was going to be a high-powered station to be in contact with Navy ships around the world. But the alternator wasn't ready at high power, so they went with Spark, one of Fessenden's rotary sparks, even though they knew it really wouldn't meet all the requirements that the Navy had. At the same time, one of their competitors, who had a continuous wave transmitter based on an oscillating arc, talked the Navy into putting one of those arc transmitters into Arlington just to see what would happen. Well, as the Navy used the two systems, they learned rapidly that Spark was not able to give them worldwide coverage, but the ARC was. So in fact, Fessenden was right. Continuous wave technology is superior to Spark. So the Navy canceled NESCO's contract, and they outfitted their stations at the time with the continuous wave using ARCs. And then NESCO really never capitalized on their being in the lead on radio telephony. Walker and Givens wanted to just sell their company to a larger company, much like many entrepreneurs do today, right? And their last hope was AT&T, the Bell telephone system. And of course, they had that very successful demonstration, which was written up in the Bell Telephone Technical Journal. Unfortunately, in 1907, the telephone company goes through a major reorganization, and they de-emphasize, or downsize, as we would say today, most of the upstream and long-term research. And so AT&T was not interested in pursuing radio telephony at the time. And maybe next month we'll find out more about the history of AT&T and radio telephony in the speaker next week. There is a connection between NESCO and RCA, and it's somewhat tortuous. So by 1911, Walker and Givens have invested about $2 million in NESCO, which today would be on the order of $60 million. And they're frustrated with Fessenden. Fessenden is frustrated with them, and in fact, he starts a Canadian company, which Walker and Givens see as competition against NESCO. So in 1911, they push Fessenden out. But Fessenden sues for breach of contract. Remember the original agreement I talked about? Walker and Givens had the option to purchase 55% of NESCO for 9 months. They never did that. So in court, Fessenden wins his case, and the court awards $400,000 to him. NESCO appeals and actually wins on the appeal, but Fessenden continues the fight. Now, with this large potential liability hanging over their head, NESCO goes into receivership. And it really doesn't produce much over the next 10 years or so. Interestingly, in 1920, Westinghouse wants to bolster their radio patent portfolio, and they acquire the Fessenden patents by buying NESCO. Westinghouse, Fessenden's old friend. And in 1921, Westinghouse joins the RCA, what was called the Radio Trust, which means that they license the Fessenden patents to RCA. So RCA now becomes responsible for the litigation with Fessenden. And in 1928, RCA settles with Fessenden for $500,000, which today would be $9 million. Fessenden does report to the IRS that his lawyers took 40% of that. So let's look at his radio technology and what happened to it. His heterodyne principle is really important to radio over the next many decades. I mentioned 1912, Edwin Armstrong patents the crystal vacuum tube oscillator, and he also patents the super heterodyne receiver, which combines that local oscillator with the heterodyne mixing of radio signals. And that's the basis for high-performance radio receivers for many, many decades, and it's probably only being replaced today by the digital revolution, by software-defined radios. And in fact, in 1924, RCA sells a commercial super heterodyne receiver, and in today's dollars, it was about $5,000. And the radios that are on display in the museum next door, the HRO 500, the CR88, they all use the architecture of super heterodyne. And in fact, today, if you listen to Morse code by hearing the audio sound in headphones or on a speaker from a radio, that last step is to mix two frequencies to get that tone. The radio frequency alternator, GE continues the development and ends up being able to produce alternators of 200,000 watts and typically up to almost 100,000 hertz or cycles per second. And globally, they end up delivering about 20 of them. And as you'll find out in the museum next door, if you haven't been there, after World War I, Marconi needs alternators to populate his stations. And that actually spurs the creation of RCA in 1919. Two of these large alternators are installed at Marion, and they're operated from here in 1920 and 1921 for past to Norway and Germany. And one of them remains in service into the 1950s. Well, it turns out Fessenden was right. Continuous wave transmissions are superior to spark. And radio theory gets modified. Ambrose Fleming removes that comment from his treatise in later editions. The spark era ends in the 1920s, and all the transmissions by WCC were using continuous wave transmissions. Radio telephony, right, voice, music over radio. Broadcasting takes off in the 1920s. RCA rides those waves through radio and television. So let me wrap up with this slide. In 1919, Fessenden and Reginald and Helen buy a house on Woburn Road in the Chestnut Hill area of Newton, just outside of Boston. That house still exists. It's a private residence, and it's on the National Historic Register. In 1928, with the proceeds from the RCA settlement, he and Helen buy a large home in Flats Village, Bermuda, where they get to go back to their roots. And 4 years later, at age 65, Fessenden passes away of a heart attack. I would like to thank Dick Cracer. He provided some wonderful documentation of the work at Brant Rock. And I'd like to thank you for your kind attention. I'm happy to answer questions. Yes?
Can you say a little bit more about alternators in the radio context? Were they mechanical devices, electrical, some combination? What was it that caused them to generate their output?
Sure. So the question is, can I explain a radio frequency alternator in a few words? Basically, if you think about an alternator that makes power for our electrical outlets, it's a 60-cycle alternating current. If you can build an alternator with enough poles on it, enough coils on it, if you think about it in terms of coils, and you spin it fast enough, you can make that same alternating current at higher and higher frequencies. So they were electromechanical devices. Some of the important things, the frequency is determined by the rate of rotation, the RPM of the armature. So as you send dits and das, you need to make sure as you load and unload that alternator, you don't slow it down and speed it up. So there was a lot of control circuitry. I can tell you, if anyone's interested in learning more about that, there's wonderful YouTube videos about an alternator in Sweden at Grimeton. That you can just put RF alternator Sweden in the and they actually still put it on the air a couple times a year, and it takes a couple hours to get it up to speed and get it running. But it's a marvel of electrical and mechanical engineering of the era. Yeah, Jeff.
So it could be a convoluted question, but was he famous in his own time? Or was he just considered someone that, kept trying to do something and ultimately failed several times? And only as the 20th century and the 21st century went on, have people gone back and realized what a contribution he made, how brilliant he was. He may have been a little stubborn, but it doesn't seem like a name that, you hear Marconi, you hear Edison, you hear Tesla, you hear Sarnoff, you hear all these pioneer guys that are like gods in their own countries. And this guy just never heard of him. And I'm not saying I would know who he was, but did he become more famous after he died? Is basically what I'm saying.
Well, so the question is, he's not very well known today. In fact, let me see a show of hands. Anybody heard of him before I posted my talk? No hands. One hand went up. Two hands went up. Yeah, so he's not well known today. So the question is, was he well known in his time? Or is it more now that we know about him? I think he was actually reasonably well known in his time. That New York Times article, the fact that people like the Weather Bureau sought him out. He did publish quite a bit. He published in Scientific American. He published a long rambling series in a radio journal in the 1920s. And in fact, the editor cut him off and didn't let him keep going. So I think he was known among his contemporaries at the time. But then I think because there weren't commercial successes that drove his name out there, I think he's a bit been lost to history.
Yeah, I mean, I'm just thinking about other scientists and researchers who their brilliance was only discovered, someone they'll call like continental drift and all that kind of stuff. The people said that didn't happen. Now, of course, all the research shows that it did. I was just wondering if he was sort of in that group but it doesn't sound like he is.
So was he in the group of people who later on we realized how brilliant his was and how fundamental his invention was? I mean, some of his inventions were fundamental, but they did require further development and further invention to become practical, like the heterodyne mixing thing. And then, of course, the radio frequency alternator had a limited life as vacuum tubes took over, and he didn't play any role in that. Did I answer your question? No.
Tom Scott asks, is there anything left of Fessenden on Brant Rock?
So there's a little bit left at Brant Rock. There is the insulator. You can find the large glass insulator that it was the base of his tower. And in the slide that I showed where I played the audio clips, there are some plaques about him and what he did there. There are even plaques on Cobb's Island about his radio telephony. I don't think there's much left. There is a large glass insulator left in Machrihanish, Scotland as well. And there's a Fessenden fan society in Scotland who keeps it alive, but there's no museum, you have to know where it is and then you'll just come upon a big hunk of glass.
Any other questions? Okay, well, yep, got one? Go ahead.
Late on one of the later slides, you mentioned that the Fessenden patents were acquired with Westinghouse, or was it? I think it was Westinghouse, I think you said. And then you called out specifically 3 very foundational patents in the course of your talk. Was the set that was acquired essentially those 3, or did he have a large portfolio of patents and you just called out a few that were representative?
Yeah, so the question is, when his patent portfolio was acquired by Westinghouse, was it just a few patents that I talked about or many? He had hundreds of patents, and I really did cherry pick the ones I thought made it an interesting story, and also the ones that I could relate to what happened here. He had many patents in the radio space. His antenna, I showed that antenna that sat on the glass insulator. He patented that. He patented other detectors and so on. And then when he turned his attention to underwater sound detection, so sonar or passive sonar, he had a lot of inventions there as well. So the Westinghouse portfolio would have been the patents that were still active in the radio space because they came from NESCO.
Yeah, there's an interesting sidelight to the Westinghouse acquisition of Fessenden patents and use. This is something I think that Ed taught me as a docent at the museum. GE actually was instrumental in forming RCA. They were approached by the Navy to do that, to be able to keep the radio patents in the hands of Americans following World War I. And in the process of the post-war transfer of stations from the Navy back to what was originally American Marconi and then RCA, and RCA's acquisition of patents and so on, RCA was setting up shore stations here and in Europe, and Westinghouse was watching all of this as a rival of GE and said, well, GE went and did this and created RCA, and we can get into that business. And they sent somebody over to Europe to try and line up shore stations, and they were too late. RCA had gotten there first, And so Westinghouse basically gave up and then gave their patents over to RCA instead of actually trying to go into a competitive business. That whole history, if you've never gotten into it and have a chance to go look at the RCA exhibit in the museum, is fascinating because it combines a lot of diverse elements that fed the creation of RCA in that post-World War I environment. Oh, just a comment, it was a great presentation. Thank you, Tom. We are,
One more question.
oh, one more question, okay.
You don't have to go back and find the slide, but at one point you said there were two of those monstrously sized alternators in Marion. So after the war, as you know, we moved the transmitting station much closer to here into South Chatham. And I think in Marion, there's probably a plaque and nothing else. What happened to those, were they actually transported, those two alternators?
So my understanding of the two alternators that were at Marion, and Ed, you can correct me if I get it wrong, one was moved out and actually was moved to Hawaii and was operated in Hawaii for a while. The other one, I believe, is the one that's in the Smithsonian. It was pulled out of, I don't know what happened to the other one at Marion. I thought it was the one at the Smithsonian. Ed, do you know what happened to the two alternators? Okay.
It sounds reasonable. I mean,
Yeah.
they're not there, they had to go somewhere.
They're clearly not there anymore. That's right, yes.
Okay, thank you, Tom. We are presenting you with these, with a one-of-a-kind, priceless Chatham Marconi ball cap.
Thank you, Rob.
And Jen went and raided the Chatham Candy Manor.
Oh my gosh, candy? Oh.
So thank you very much.